This video explains how to calculate returns, risk, and the variance-covariance matrix for a series of stocks. We can see here we've got 7 stocks, they're historical returns, and this is used as an input into our efficient frontier calculation. So what I've got on the screen here are the historical returns for 7 stocks: BHP, Foster's Group, Fairfax, Harvey Norman, QBE Insurance, Westpac Bank, and Woolworths. I've also got historical equity market index values, and importantly these are an accumulation index. Accumulation index means that it incorporates dividends as well as prices. And I've got a daily risk-free rate of interest. So first of all, to note that for each stock we've got the daily price values, and I've calculated a daily return. Now, as I discussed briefly in a previous video, when we're calculating daily returns, we have to add back in the effect of capitalization events and dividends. So in column B, for example, for BHP, I've got closing share prices, but then in column C, I've got any dividends that were paid on their ex-dividend date. So for example, here we can see that on the 28th of February 2005, we calculate the daily return for BHP stocks on that day as the new share price, or the share price at the end of that day, plus the dividend, minus the previous share price, divided by that previous share price. So in effect, what we're doing here is we're adding back in the value of that dividend on the ex-div date, such that these returns that I've calculated are adjusted returns. They're adjusted for dividends. Now, on each day, what I've also done is calculated an excess return for each stock. You can see this is the same across all 7 stocks. The excess return just being for that day, the return less, and in column AG, I've got my risk-free rate, so my daily return less the risk-free rate of interest. So that's all quite straightforward and follows what we've done before in terms of calculating returns. So therefore, if I go further down the bottom here, what you can see is that I've calculated daily average returns, which is simply just the average of all those daily return values, and I've done that for each of my stocks. Okay, so if I were to look at each of these companies along the top here, and I can, if I wanted to, freeze my top rows so that I can see which companies I'm referring to, I can see that this is the daily return for Foster's Group, daily return for Fairfax, and so forth. Now, equally as we've shown before, I can also use my standard deviation formula to calculate my standard deviation of daily returns. Now, the next issue is if I wanted to annualize these values. Now, what's important to note is that if we were to annualize returns, then what we can do is we can multiply the average daily return by the number of days in each year. Similarly, if we were to annualize variance, we take the variance value and we multiply that by the number of days in each year. But because standard deviation is the square root of the variance, then to annualize standard deviation, we have to multiply by the square root of the number of days in each year. Okay, that's just follows naturally from the fact that annualizing variance multiplied by number of days in the year. So if we took the square root of both sides, we would get daily standard deviation times square root of number of days in the year. Now this gets a bit tricky because you might think, well, there's 365 days in the year, but what we know is that the market is not open all 365 days. So it's not open on weekends, public holidays, and so forth. And there's not a fixed number of days in any year that a market's open. So what I've done is I've actually calculated across this sample period of 5 years the average number of days that the market was open. And how I did that was that I added together the total number of observations in the sample, which we can see here was 1,304. So it's 1,304 days across each of the 5 years. And if I take 1,304 and divide by 5, because there's 5 years in my sample, I get 260.8. So on average, there is 260.8 days in each year, and I'm using that to do my adjustment. So my annualized standard deviation is my daily standard deviation multiplied by square root of the average number of days per year, 260.8. And I do the same formula along here for every company. So you can see it's just replicated, but for each of these different company names along the top. And right along the end here, I've also got the same for the market index as well. So that's nothing new, we've seen all that before. But what becomes important when we're looking at risk and return of diversified portfolios is that we need to be able to calculate covariance matrix or correlation matrix. Now, what you'll recall from previous studies is that both covariance and correlations are measures of the relationship between two time series. So a covariance between two stocks is the degree of co-movement, or the relationship between the daily returns of those two stocks in this particular case. Covariance is our formal statistical measure of co-movement or relationship, but often in finance we standardize that measure to get correlation. And correlation we standardize by dividing by the standard deviation of the two series. And what that does is gives us a measure that is measured on a scale between -1 and +1. So it's just a little bit neater to use, but often we stick with the pure measure, which is the covariance, the statistical measure. Positive covariance obviously means that they move together in a positive direction or positive relationship. Negative covariance implies a negative relationship. So to calculate the covariance between each of these stocks, and now once again what I'm doing is I can calculate my daily covariances using the formula COVAR, C-O-V-A-R, and then in parentheses include the two series that I'm working with. So in this particular case, if I wanted, for example, the covariance between daily returns of BHP and daily returns of Foster's Group, then I could just calculate covariance between BHP daily returns and covariance between Foster's Group daily returns. Now, covariance is like a variance term, and in fact, the covariance between an asset and itself is actually its variance. Therefore, if I've got daily covariance and I want to annualize it, then just like annualizing variance, I multiply that by number of days in the year. So I multiply by 260.8, and the value that I've got in this cell here is the annualized covariance. The reason I'm annualizing data, it's just easier to work with annualized data rather than daily data, given the magnitude of daily returns and daily standard deviations tend to be very low. So what I can actually do in this matrix down here is that every formula is just the covariance between the two names that are intersecting. So for example, the cell I've got here, we can see it's Foster's Group and Harvey Norman. So if I can scroll up a little bit, I can see that the two series that I'm taking the covariance between are Foster's Group and Harvey Norman, and I'm annualizing by multiplying by the number of days in the year. Now, along this diagonal axis here, through the middle, so for example, this cell here is the covariance between BHP and itself. And as I said earlier, that actually just becomes the variance of BHP. So I've actually got variance values along this axis, which is why this is called a variance-covariance matrix. Now, what we also often see is at the moment I've just got a triangle shape, and I can populate the bottom half of this matrix here. What I know is that it's just a mirror image of the top half. For example, the cell that I've highlighted on at the moment, the covariance between Foster's Group and BHP, obviously that is just going to be the same as my calculated covariance between BHP and Foster's Group up here. And if I wanted to, I could continue and just repeat the top half of the matrix down the bottom just by identifying the relevant calculation from the top half of the matrix. Now, in my correlation matrix up here, I've done exactly the same thing, only I've now used the correlation formula, which is equals CORREL, with the values in parentheses. And on the diagonal, you can see I've now got the correlation between a stock's return and itself, and the correlation between a stock's return and itself will always be 1, which is why these diagonal values here are 1s. Okay, next thing I want to do is I want to calculate the beta of each of these stocks. So I've calculated average daily returns, standard deviation of daily returns, and I've annualized those standard deviations. I've generated a variance-covariance matrix, which I've annualized. My other key measure of risk is going to be my beta. Now, as I've looked at in class previously, there's two ways that I can calculate my beta. One is I can use a regression, where I can regress excess returns of the stock on the excess return of the market. Or the second way is actually use a formula, because beta can also be calculated as the covariance between the stock's excess returns and the market's excess returns divided by the variance of the stock's return of the market's excess returns. So what I want to do is I've got the beta value here calculated using the formula. What I want to do is I want to replicate that value using my regression model. And then once we've shown that it's the same, we can take for granted that these other formula calculated beta coefficients are also going to be correct. So I want to get this beta value of 1.55. So how do I do that? Well, again, using my regression model, remember, I go to Data and Data Analysis, and I select Regression. My Y values is going to be my excess return on BHP stocks. My X values is going to be my excess return on the market. So I'm going to come right across here, get excess return on the market return minus risk-free there. Select that value. So I've got my Y and my X. Click OK. Get my regression model, and we can see I get that value of 1.55 once again as before, being my estimate for the beta of this particular stock. So we are going to get the same result either way. Now, sometimes you might find there's actually a really slight estimation error. That's the difference between the calculation being based on a sample or a population. That's a really complicated sort of statistical issue that we won't go into in this particular course, but you'll find that you don't need to worry about the slight rounding errors. The beta estimate is just that anyway. It's an estimate. So even though you can see there's a very minor rounding difference here, that there are statistical reasons for that, but you could use either of those values in it and it would be correct. Okay, so then we've got the beta for each of the other stocks along here. Now, the next thing I want to do is, once I've got the beta, so I've got my historical returns, which is the returns across the past, but what I also want to do is I want to calculate the expected return of that stock. And we can remember that we can calculate an expected return using the CAPM model. Using the CAPM, expected return is just risk-free rate plus beta times expected return on the market less the risk-free rate. Now, in this particular example, I'm going to assume two inputs. I'm going to assume that an analyst forecast has told us that the expected return on the equity market is 9% per annum across the next year, and the expected risk-free rate of return is 5%. Okay, so we're taking those from some sort of expert, and we're taking those as a given. So I can calculate my expected return then for BHP stocks as being that risk-free rate, which I just said was 5%, plus my beta value from above, multiplied by my market risk premium, which is just expected market return minus risk-free rate. So if expected market return is 9% and expected risk-free rate is 5%, that market risk premium must be 4% there. And I find that my expected annual return for BHP, given this relatively high beta that we've got here, is 11.2% per annum. Now, equally, I can also work out an expected excess return. Remember, excess return just means return less the risk-free rate. So I can just substitute subtract the risk-free return from my expected return. Given that expected risk-free return was 5%, 11.2% minus 5% is 0.062. An alternative way I could have done that was recalculating my CAPM model, but just not adding the RF value into it. Along here then, I've got the expected returns and expected excess returns along with the betas for each of the 7 stocks in the portfolio, all calculated in exactly the same manner. So that gives you an overview on how to calculate covariance matrices, betas and expected returns using data in Excel.